So once we figured out that a situation is indeed a binomial probability scenario, how is it that we would calculate the probability? Well, the probability of whatever the number of successes is you're supposed to find is calculated the following way. You will take the total number of trials or repetitions or whatever you want to call them, and then you will do a combination of the number of successes that we are asked about. So for example, on the ones with the dice, if we wanted to roll 2 4s out of 6 attempts on a die, it would be 6 choose 2. 6 rolls total, choose which 2 of the 4 rolls, or which 2 of the 6 rolls we would roll that specific number on. Then once you do that, you will multiply by the probability of success for one single trial. So for a dice, that would be 1/6. And then your exponent is how many successes you're going to have. So how many 4s we said we wanted to roll, say 2. And then you'll multiply that by the probability of failure, say on a single roll of the dice, 5 out of 6. And then the exponent is the number of failures, or the number of times you do not get the roll that you need. And that is how you calculate a binomial probability. Okay. One special note that it's worth remembering is that the probability of success plus the probability of failure has to equal 1. Okay. Every single time, a success plus a failure has to equal 1. So let's work through this first example, and we're going to round all of our answers to 3 decimal places in this example. We roll a die 5 times. So notice that's your total number of trials. Okay. What's the probability you roll exactly 2? This is our number of successes, 6s. Okay. So rolling a 6 is considered a success, and then not rolling a 6 is considered a failure. So let's take our scenario up here. We need the total number of trials, 5. Choose how many successes we're going to have, or in other words, how many 6s are we looking to roll? 2 of them, times the probability of rolling a 6. The probability of rolling a 6 is 1 out of 6, and the exponent is how many 6s we want to roll, 2 of them. Then we want the probability of not rolling a 6, which is 5 out of the 6 sides of the die. And how many times we would not roll a 6 would be 3 times. So again, this is all about a success, or in this case, rolling a 6. And this is all about not rolling a 6, having a failure in this case. Typing that into your calculator, and you can go ahead and type the fractions exactly as they look on the paper, and rounding to 3 decimal places, you will find the probability is 0.161, or about 16.1%. All right, so let's look at a prescription drug. It causes dizziness in 20% of all patients who use the drug. Among a random sample of 10 patients, find the probability exactly 4 of them have dizziness when taking this drug. So when it comes to these 10 patients, that's your total, okay? 4 of them is what we're going to consider a success. So we're going to consider a success to be dizzy. I know that seems a little backwards, but really we have 2 categories, dizzy and not dizzy. And so there's our success and our failure. It really doesn't matter which one we call which. So we're going to take our total number of patients, 10. We're going to choose which 4 of them experience dizziness. And then this part here is going to be about the people who are dizzy. So what's the probability they experience dizziness? 20%. How many of those 10 patients are we trying to find out would have dizziness? That would be 4. And then we want the probability that they don't have any dizziness. Well, again, if 20% of them experience dizziness, then 80% of them will not. And out of those 10 patients, 6 of them would not be experiencing dizziness. Multiply all that together, and you will find the probability is 0.088. Now, in this next scenario, I'm going to let you set it up, but I want to point out the words at least 7. So remember that means a minimum of 7 free throws are made, which means that you're going to have an or scenario. He makes 7 or he makes 8 free throws, which means you're going to need 2 of those little binomial scenarios added together. So please take a moment to set them up, then come back, restart the video, compare, and see how you did. Okay, so check the setup. Any questions again that you have about this scenario? Remember, at least 7 means he makes 7 or he makes 8. So I've got the details outlined there, but any questions that you have, again, please post them to the forum. And even if you don't have a question, be reading the forum. If you understand that, read the forum and provide your explanation to one of your peers who may be struggling. Your words may be the exact words that they need to hear in order to understand this concept.